As Em said, I'm Ed. Until very recently, I was Google's geospatial technologist. I'm in the process of moving on and doing a new adventures, whatever that might look like. But for the meantime, you can still think of me as Google's map man. I was involved in the development of Google Earth, bringing Street View to the UK all those years ago. So before Google had a background in the National Mapping Agency here, Ordnance Survey. Before that, I was an academic dealing with Earth observation, remote sensing, which you're going to hear quite a lot about during the talk this afternoon. Enough about me. Let me hand over to Dean. Just tell us a little bit about yourself.
So, right, hi everyone, and thanks OpenUK for having me. So, maybe just to introduce myself very briefly, I lead a small research and engineering company in Cambridge. On one end, we work with institutions and do science for them, particularly for urban and sustainability. And on the other end, we're an engineering team for Earth observation data, and we do a lot of data science analysis for all sorts of different people that deal with forestry, fishing, agriculture, the normal businesses that end up using Earth observation data in the end.
Cool, hopefully this is working. I'm not going to give a long introduction. So Denise Mckenzie, managing partner at Place Trust. As some of you in the room will know me from many moons ago, I've had lots of different hats in this sector, definitely fit in the category of a digital geographer, I think of about 25 years. So sitting here today, I guess, as somebody who has worked particularly in the last 15 years across the international stage of dealing with both geospatial and Earth observations data in a huge variety of different ways. So looking at policy, looking at data governance, and I think really probably more recently looking at around the ethical and responsible use of this type of data as well. So just interested to see where our conversation goes today.
Great. So, as there's so few of us, do feel free to butt in. We are going to act rather than a formal kind of panel like we've just met in the pub and we're having a chat about space because we love it all so much. So do feel free to interrupt as we're going along. We'll, if you don't, we will give you time for questions at the end, but do feel free to butt in. Chris.
When's the pub quiz? Yeah, we haven't done one of those for ages, Chris.
Yeah, we should. Maybe we'll do that next year. We'll get a bigger audience for a pub
Yeah, we
quiz.
might get a bigger audience.
Okay, so to put this into context, and I think it's useful, space actually, the UK is very successful in space. Space industry tends to be relatively often viewed as an upstream and downstream business. Upstream is the rocket science, i.e. building satellites, of which actually UK is a very big player in, although often not recognised. Launching, less so. We're trying to get much more involved in that. But certainly the operation, the design of satellites is a big piece. Probably, though, what we're going to talk much more about is the downstream use of data and services and applications that are derived from space. There are many uses of that. The industry, last time I looked, was probably worth about £20 billion per year in the UK. The services part of that, we are probably the second largest country that obtains value from space services. So it's a big deal. Amongst those services, there are clearly things like communications, your satellite TV. Increasingly, it's going to be available direct from satellite communications to your mobile phones. That's going to be a big growth area we're going to see over the next couple of years. Positioning, navigation and timing, GNSS, but also the GPS systems that we're all very familiar with. But an important element to that is the timing bit, the T, in PNT. That's very much a invisible but vital component in a lot of online infrastructure that we currently use. Most online services make use of timing signals that are coming from space. They're invisible. They're also very fragile. There's a lot of focus on building more robust PNT-based solutions. But what probably we're going to talk mostly about is the area of Earth observation, i.e. taking images from satellites and then using the data that you can then use that from those satellites derive information from that, and then make that available in an open fashion. And that's the key part. The industry has been around probably 60, 70 years. For the last 30 years, there's been a much bigger commercial component to the industry than there was initially. But it's something that is intrinsic in many ways to science in the UK, particularly environmental science. And I think, Dean, you're probably the guy that can give us that kind of broad perspective of where does open science, particularly open science coming from space-based data, where does that sit in the UK economy?
So it's a very important conversation to have case studies and to have a discussion about how it's useful just by itself. Because Earth observation generally is a very technical field that basically has a lot of technical folk that don't deal with management. And what happens then is a lot of people get, prepared these slides, a lot of information, these 30, 40-minute technical explanations about how everything works. But then a CEO comes in and tells you and hits you with a, give me the 2-minute brief, I'm out, I need to know it now and goodbye if I don't. So it's very important to basically have a very concise return on investment explanation about how the data and how the data is going to be useful. And that's what's going to enable, in the first instance, to keep the data open in the first place for the economy, for the government, for scientists, and so on. But maybe to talk about how that data ends up getting used in the end. Basically, it goes into two categories. It goes into, first, the things you don't really see that aren't, that impressive on the first instance, like GPS, right? It's on your phone. You don't really care about it. It's there. But there's an immense economy behind that. It's an ecosystem in by itself. There's the upstream applications that, the rocket science launch and everything else. And the downstream is even bigger when it comes to applications and the amount of software that gets written for that. There's also 3/4 of all the climate change key factors that are getting monitored are basically based on satellite imagery data of different types. So, that is all Earth observation analysis that's getting done by science, and most of that is getting published as open data by different organizations like the European Space Agency, NASA, and so on. For scientists to communicate and essentially share information between each other and fight essentially climate change. But the really interesting thing that comes in is when it's linked with economy and normal businesses, I'd say. The UK predicts that by 2040 there's going to be a massive market for these types of applications, and all sorts of Earth observation data is going to get used for different industries. For example, we've worked with a lot in the sustainability industry, and there you can see it getting used regularly now to do things like account trees identification, biodiversity, things like carbon estimation of buildings, trying to seek from the thermal signature of building, trying to estimate what's going to be the carbon emission of that building, and that serves government and economies for like different purposes. But there's really regular businesses as well that get affected. Like, for example, agriculture is one big thing where you will be able to, and people are already doing this, able to monitor crops from space and how they're developing, whether there's any pests for particular areas, and then treat them reactively instead of having to proactively search manually, you know, with going through big fields with a tractor and trying to see what's happening, or using other sensors. Fishing is also something that's fairly, that you wouldn't expect that you would get impacted, but you would be able to, and people are again doing it now, trying to find fish populations and either defend them to ensure biodiversity and ensure species safety, or enable fishery to find ample fishing spots. But yeah, it's like a very vast sector, and businesses really tend to not realize the benefits of this data. And when it's communicated correctly, that's when the benefits really happen, when there's a clear return on investment from them. But Denise, what do you think from your perspective and your experience from sharing all the data from aerial footage and so on?
So I guess to explain a little bit about where I sit here in this conversation is actually Place doesn't work with space data as such, though what we do is what you might describe a little bit as being the last mile. Many organisations that use satellite imagery will find that its resolution gets down to a certain point in looking at the Earth's surface, and then there is, in the same way that a logistics company looks for then the driver that's going to take it and get the item to the house. Aerial photography and what you might describe as in situ type imagery, such as from street view cars and those sorts of things, is the last mile. So place is about trying to add the extra bit, if you like, on top of the satellite imagery in there. I don't know how much more detail do we want to go in scene setting at the moment.
We're going to drop into some more detail, I'm sure. I'm going to push back a little bit, because it all sounds rosy and wonderful that governments, in their wisdom, 60, 70 years ago, as a spin-off of the space program, decided to launch these Earth observation satellites and to make the data freely available to people. Why aren't we all using it then? If there's this great free resource out there that people have spent huge amounts of money putting these satellites into orbit that acquire all of this open data, why isn't it a bigger deal?
It's hard. So let me give you a couple of things. I think we also go back that 60 years, look at where that investment came from. That was the defence and intelligence community that were doing that. So there's a heck of a lot of money. There was a heck of a lot of compute power that was going into using that when it was first done too. That's taken a lot to get to the point where you have got processing to be able to do that. So I think that part of it alone is hard. So size, power, also we're collecting more and more and more of that too. So in the same way, bigger data sets, harder to compute. The other thing is, I think that probably we haven't been looking at as a skill set either. I think increasingly it is still specialist, trying to interpret and use that imagery and be able to pull out the information that's there. I think that's got increasingly hard. I'll put a slight rosy in here though, because I think one of the things about this sector is that it has been doing machine learning and I would argue AI probably far before it became a buzzword of interest, looking for features and looking for changes in there. My hope is actually that we're getting to a point where hopefully some of that becomes a lot easier. And so to get to your point, Dean, about people realising the benefits of it, I think actually we're on a really interesting point at the moment where that might be able to help improve the way that it is adopted.
Dee, before you jump in, I'm just going to make use of our very knowledgeable audience here.
I know, because I could see Chris's face.
I'm just going to talk to Chris here from the Met Office. Do you want to talk, very briefly introduce yourself?
Okay, I'm Chris Little. I've worked with the Met Office for decades. I've had several careers there, and the last 10 or 15 years, I've got to know Denise and Ed through geospatial, because basically my job is to change the world to suit the Met Office. And I've been around a long time, so I've seen the earliest satellites, and there's some really interesting things that happened, right? So when the first meteorological satellites went up, and then they came to and it was sort of useful, but basically the forecasters had a big red button to say, please exclude the satellite data because it's rubbish, and the forecast improved. It's the other way around now. They're essential. But when the first satellite was starting to come to the end of its life, it's running out of hydrogen or whatever, and it's going to decay, and you need another one, you went back to the space agencies, ESA and NASA, said, we'd like another one of those, or maybe two, but can we have it 10% cheaper? And NASA and ESA did not like that. They wanted to go where nobody had been before, right? The classical Star Trek stuff, we don't do business as usual. Which is why the Europeans set up the EUMETSAT, a European organisation whose sole job is to put up European meteorological satellites. So that's one kind of aspect. And at that time, the data was open. But then we had a political change. And as Ronald Reagan said, why do we need the National Weather Service in the US? Because I can get a weather forecast from CNN. And why do we need these satellites, which are expensive, and other people are using them? Well, you did sign an international treaty. So is this, and of course then there's the push to privatize everything, right? And therefore some of the satellite data start being encrypted. That's it.
I think that's really interesting. We'll come back to that geopolitical point. But in terms of why is it still so difficult, despite the fact that it's open? Dean, can you help us? Why is it so difficult?
I'm curious.
Oh, and then we'll come back. Dean, you'll go.
it's just complicated to work with the data. Like in the first instance, it requires like specialized skill sets. You have to be a data scientist, know about AI, and then some more. So, if you take something like, let's say, synthetic aperture data, radar data, it's not really simple to handle in the first place. Like you need to know what it is, which is by in itself like a whole course, and then you need to know how the tools work around it. And then you need to combine it with other sources of data like metadata or imagery data, or then insta data of a certain place and geolocation and all the other features. And basically, at the end of it, it becomes a very specialized product. What people need to focus on is to talk about not only data, but open science at the same time, because what a lot of these institutions do is they will produce a lot of reusable workflows and a lot of reusable products at the end of them. Maybe it's the data, maybe it's the algorithms. All of it can basically be published and reused instead of having people redo the same engineering again and again. And that's where you get really useful value for normal businesses, where they don't have to have a whole research department around satellite imagery to use Earth observation data.
Okay, can you help us on the accessibility? Introduce yourself.
I'm Tushar Sethi. I run two companies in the UK. One is a for-profit engineering consultancy. We focus on data fusion using machine learning methods. And using data, multi-sensor data. And the other company I run is a non-profit educational enterprise. We train scientists and engineers in geocomputation using open source tools and again, with a focus on machine learning frameworks. As Denise said, one issue here in the proliferation of space data is skills. I think there are countries, including the UK, that are lacking in those skills, and that starts at the university level. We see that because we get attendees on our course from all over the world. We run about 3 courses on average a year, liaising with universities from all around California, Berkeley, Yale University, Stockholm, wherever. Maybe we're hard-pressed to get one person a year from the UK. And so that's skills. Then there's funding. Funding in this sector is usually the preserve of government, but off late you've seen venture capital funds. They have a very specific agenda, and I don't think government knows that they have a specific agenda, and they will only invest in a very, very narrow range of businesses that deliver a very narrow range of products. So you can't fund a fledgling sector with VC funding exclusively. It has to come from grants. It has to come from other sources of funding that look at a different kind of a wide range of business propositions, not just a VC fundable business proposition. And then is the general the other stumbling block is the general awareness of the applications. Everything is focused. It seems to be focused on imagery. It's not about spectral analysis. There's a plethora of data out there. There's digital elevation models. There's SAR data, as you mentioned. There's a range of spectra within imagery, infrared, all of that. And then there's this cherry picking with applications as well, where agribusiness is well served in that segment, but not other areas like, say, disease monitoring. So I think there's a whole range of these issues that need to be addressed. I've spoken enough, but those are the comments.
No, that's brilliant, and I think it's a story that's not unfamiliar to open data, open source communities. In that, the classic "if you build it, they will come" doesn't work. Just by making this data openly available, as it has been for many, many years, it doesn't mean, unless you put the effort in terms of training, building a community, building access tools, that people will necessarily be able to make value from the data. So openness on its own clearly isn't enough. We need to do a bit more than that. But openness can help in some ways. And I want to talk a little bit now about the elephant in the room, which you mentioned, Tushar, in terms of the emergence of commercial operators in this space, and even how commercial operators can make use of open data and open source tools. There's a Canadian startup who have launched a satellite that does hyperspectral imaging. So rather than just looking at visible light, it looks across a whole lot of different wavelengths, particularly focused on geological and agricultural applications. It's a commercial operation, so you have to pay for imagery usually, but they've introduced a open data scheme where literally not even putting your email address in, you can get access to their data. It's made in a cloud native format, very straightforward, very easy to use. I guess the question for you is where do you see the commercial sector and the traditional public sector coexisting in this space, and is openness the bit that connects them together? What are your views?
Do you want to go?
You can go.
So as it stands at the moment, like typically the public data is going to be far worse than commercial data, and I don't think that's about to change. And even the publicly funded satellites like, let's say, Pleiades, Pleiades, they're like, again, they have a commercial model for them and aren't open. And that's going to be there to stay for the next short while, just because it's an economy in by itself, and people can make money and they will make money from it.
Denise?
So I think it's interesting. I mean, if you look at something like Place as an entity, it's probably a response to recognising that a collection of data is expensive. Trying to find mechanisms to be able to make things open is hard, actually. Funding is really hard for that. And a lot of governments around the world too went on, even the ones that were hugely supportive of being open data have now gotten to a point where they're kind of going, this is expensive to try and put these things out. So I think there's the interesting thing about the commercial sector is that there's this quest still to find better business models that mean that you can both collect and produce fantastic high quality data consistently and make enough money along the way to be able to do that. So I guess from a Place perspective, what I think with some of this is I think we need to start thinking a little bit more about some of this data as a common good, and think about it more from that sense of how do you create structures that enable the data to be collected but then made available in such a way that many people can use it multiple times in different ways, and you can create a financial sustainability in doing that. So I think for me, that's the sort of next frontier, so to speak, in the commercial sector. In that, from a government and a commercial side, there's a lot of different roles those two things can play, I think, when you look at it. So the government might be a funding entity, it might be a user in here, might be helping be the regulator in that space as well. And it's about building, I think, a structured partnership between the private sector and the government in that regard. I think it's not the responsibility of either one to do it by itself. And I think if either one tries to do it by itself, it'll fail in there. So I think for me, it's always about bringing those two things together.
Interesting. I guess this leads us on to, in some ways, a discussion we were having before lunch. I don't know if anyone was in the room, where we were talking about copyright and its use in the context of AI and AI training. Now, a lot of that focuses on generative AI and the use of large language models. As I think Denise, you pointed out, we've been using other forms of machine learning for literally decades to process satellite imagery and to be able to extract features from that imagery. Do we see, collectively in the room, a potential conflict now between that relatively broad use without any encumbrances of imagery up until now? Is that under threat by people wanting to extract their pound of flesh from imagery? You're someone actually who works in AI and imagery. What do you think? Is there a conflict emerging?
Conflict between
imagery providers and people who want to do AI on that imagery?
I think there's the imagery providers, if they're private companies, it's proprietary. So there's the issue of cost and geographic scale. So if you're doing large-scale geographic studies, imagery is automatically written off as unfeasible. And therein lies the problem, and hence the need for open imagery, open data, whatever kind.
What about open data providers? Do you think there are people in NASA or ESA today, people running the Landsat program, the Copernicus program, saying, are we okay with our data being used to train AI models that we have no control over?
I haven't seen any objections on that front. They make their data freely available. In fact, all our work is heavily reliant on open access data. We don't use any proprietary data unless it's required by a customer, because we do large-scale studies, large geographic scale studies. But I haven't seen any concerns raised by the likes of ESA and NASA, and I don't think they're monitoring it. But someone else may be better.
I'm just going to take up on Ed's word freely. It may be freely available, but actually there's a real cost of getting that data because it's so big.
And of course, being a libertarian, say, well, actually, you've paid for it with your taxes anyway, so it's not really free. What do you guys think? Is there a possible conflict there between imagery providers and people using it for exploiting via AI?
So they're actually encouraging it, and they have funds, essentially, to fund projects and pre-commercial ideas that use Gen AI over satellite imagery. And so it's like growing field that, and they're interested in it. I don't think it's like there's a conflict in particular about it. It's an active sort of research field, more or less, that they're interested in commercializing.
I think it's coming. I think it's bubbling now, and it will come when you get countries that want to take the opt-out clause and say, yeah, that's lovely, NASA, that you've been imaging the surface of the Earth all around, but I don't want you to show my country anymore. And I think that's the, if you like, geopolitical cliff that we're coming towards at the moment. And you only have to look at the last 3 weeks internationally from the impact on the tech sector to know that if I'd said this 5 weeks ago, you might have all kind of looked at me a little bit funny and gone, no country's going to do that. But now, I think if you look at some of what the world leaders around the world are now looking at in the United States, thinking we once upon a time knew this country. We once upon a time knew and could rely on what they were going to do in terms of tech policy and what they were going to do with data. I'm now not so sure. Therefore, I might not be happy any longer that NASA is collecting images of my country all the time. I might start investing in technology that blocks the ability somehow to do that. Or I might actually decide that I don't like their satellites anymore, being able to do that and take some sort of action against that. I think it might sound fantastical what I'm saying, but actually I think you only have to look at some of what's been occurring in the last 3 weeks to know that that conflict is absolutely coming, and it will 100% threaten what we have thought of as open data and open science globally from that. And I think that data sovereignty issue, it'll permeate way past satellite data and into a whole raft of different types of data as well that hopefully actually might have implications for some of those big tech platforms.
Yeah, and that is a slightly different point, but you're absolutely right to raise it. Here the concern is less about the use for AI training or whatever, but that fundamental security aspect in terms of data sovereignty and the ability now for, we kind of joke, almost if we put our credit cards together, we could launch our own Earth observation satellite. It is getting that accessible, that cheap. Lots of countries are able to do that now. So that's a capability that's emerging. But you're right, I'm sure it's only a matter of time before the president identifies the fact that why am I spending US taxpayers' money to image other parts of the world and give the data away? You've got to remember that there was a brief period, it was a relatively brief period, where the Landsat program, which we have all come to rely on, was a commercial program and was forced to be a commercial program for a number of years by the then administration. So as a direction of travel towards increasing openness, that's not in any way guaranteed. And therefore we have to make a stronger case for the values or the benefits that open data brings us. We focused a lot on Earth observation, as of course we would do. That's perhaps the most the obvious area. What about, I guess the area I'm also quite interested in, positioning, navigation and timing, the GNSS, GPS aspect. Again, sovereignty is important there. We have sovereign systems, GPS in the United States, Galileo, Baidu, there's a regional system for India, there's another regional system for Japan. The UK have looked at low Earth orbit solutions for doing this. Where do we see this developing? And is there an open message, is there an open story for positioning, navigation and timing?
Oh man, I'd love there to be. It feels like we missed the window. I think that opportunity to some degree might have been there. And Chris, you would have been in some of these conversations, I'm thinking kind of 15 years ago, where I think we had an international moment where there was great opportunity to have had that conversation and to have really kind of forged perhaps a similar path to what the meteorological community did in building that international treaty around that. I still think the benefit is there for an international agreement around our position and timing systems. I think, really if you think about the transitory nature of our logistics, about shipping, about planes, I mean, to some degree the aviation community have done it. They've recognised that from a safety perspective, that's really important. But I do worry that maybe we sort of missed the window to really pull that international treaty together, to make that there. I mean, if you could get that international agreement around position and timing, obviously you really improve your capacity for open science and research at that point. You really start to be able to be so much more concrete in some of your decisions and assumptions about some of the things we're saying around climate change, around some of the modelling that we've been doing in the world as well. So I'm going to try and be a little Pollyanna and say I still think we can do it. But I think we're just in a really challenging political environment now to try and do it.
Yes, sir. I love it. This is just such an informed audience. There we go. Dave.
Thank you. I just had, actually going back to Earth observation data, sorry, I just had one more question in terms of kind of practicalities. What do you think the government's responsibility is in terms of enabling access? Is it processing the data ourselves and then releasing those high-value data sets as open data, or what do you think we should be doing?
I've got a response to that, but I think mine might be a bit radical.
I want to hear your response first.
Okay. I would say that the government probably doesn't have a role, and let the market do that piece. And I think that's probably where we sit today. I think a lot of the developments over the last 5 or 6 years to make Earth observation data more accessible have come from the market. You look at things like Microsoft Planetary Engine, Google Earth Engine, they are things that the market have built to make Earth observation data more accessible. The government could have done that. It didn't, and probably is not an appropriate use of tax pounds or dollars, but what do you guys think?
I'm actually going to pull a point that Dean made earlier about making cases for return on investment. Some really interesting conversations going on using two particular terms that I'll mention here in the world that are generally about data. One is called digital public infrastructure and the other one's called digital public goods. I think the way to make it, to actually argue that there is a responsibility for government is if you can characterise this type of data as an essential public good, and to then be able to easily and clearly show the importance of and benefit of having that as a standard service. For example, if you take our water system of utility that we all need fresh and clean water. Now, for many countries, actually no government delivers that to their citizens in a whole bunch of parts of the world. But in our economy, actually, we see that as a responsibility of the government to make sure that there is a provision of high quality water. There is certain data types, I would argue, in a digital public infrastructure and digital goods that I think you really can define as absolutely essential these days, digital public goods that you need in order to have a thriving digital ecosystem that supports your citizens in here. Now, right now, DPI is very much wrapped up in digital IDs and digital financial payments around the world, but I would argue that there are things like Earth observations data and a lot of location data that you can define as a digital public good in that way as well. And I think some level of Earth observations data probably exists in that space, but we haven't yet scratched the surface of that definition.
Right, exactly. And if it's a digital public good, if it's not a security risk, and if it's being publicly funded, you would assume and you would want your government to have that data open and ready for its people and organizations, to bolster the economy and get businesses to use it, and then to openly share it between institutions as well. Especially if it's like publicly funded. It always perplexes me how research is not open in general as much as it could be, and that there's paywalls, that there's access when it comes to the data is not really fair, as in it's not really findable, accessible, interoperable between different sources, and reusable. And generally, there's not a mandate to keep a standard for all of this, especially when it's government and publicly funded.
And I think it's important to recognise that there are two pieces to this, isn't there? There's the data and the production of the data itself, and then the distribution. Now, the data, its collection, launching of satellites, design of satellites, that's expensive. Government agencies are very good at doing that. The distribution, that may well change in the lifetime of that project. But Dave, have we answered your question? What do you think?
Yeah, no, I think that was good. I mean, I kind of agree that we should be defining as a society or as a public, what we should be focusing on to some extent. So there's obviously issues of sustainability, climate change, agriculture. So if we can define high-value data sets, maybe that is a role for government to kind of define those and then fund them or create them.
And I was going to say, I'll add into this too, actually, that supports Ed here. That delivery of a digital public infrastructure in the same way that we've done public utilities doesn't always have to be 100% done by the government at that point. There are different parts and roles in how you actually do it. And I think that's why I've actually really enjoyed being part of the dialogue around sort of defining what this sense of DPI and DPGs are, because I think it's a very good structure by which to start having that conversation about the different roles that government and private sector can play. And I think in different economies and different countries, that partnership is going to look different in how you do the delivery, but you can still define the good that needs to be delivered to the public.
Yeah, no, that's absolutely right. And maybe to add to that and give like a concrete example of such a system, for example, we used to have something called a network of resources, where you're able to request resources for compute and access to the data. That's not provided by them. That's provided by a third party, a commercial party, and is basically in the interest of everybody to have that operate that way. It ends up being very productive.